9.4 Electricity and the human body. Electricity has two types of hazards. We have thermal hazards and shock hazards. For thermal hazards, that's heat, the electric energy is converted to thermal energy faster than it can be dissipated. So it keeps getting hotter and hotter. That happens in short circuits. The electricity jumps between two parts of the circuits and misses the main load, or the main thing that's using the electricity, the main resistance. So since there's almost no resistance, if we go V equals IR, the voltage is set by the power source, so if the resistance is almost zero, the current has to be almost infinity. There's a lot of current. That current creates heat. Or another way, P equals V squared over R, there's a little r, so the high power, and all this heat can start fires. To try to combat that, we have circuit breakers or fuses that will trip and turn off the circuit before it gets too hot. What they do is they sense when the current is too high for a circuit breaker. There's a little electromagnet that pulls the switch open. For a fuse, it's just a wire that melts when it gets too hot, when there's too much current, and it breaks the circuit. Another way that you have a thermal hazard is if there's a long wire. If they have a high resistance because they're kind of thinnish, over a long length, it will produce heat. Maybe they're coiled up, or maybe they're under a rug so that the heat can't dissipate, and then it gets hot enough to possibly start a fire. For shock hazards, it's important to know a few factors of how dangerous the shock is to the body. First is the amount of current. The more current, the worse it is. The path of the current, well, if it goes through the heart or your brain, that's really bad. Through your heart, it could stop your heart. If it goes through your brain, it can just completely short out your brain and it doesn't work anymore. Duration of the shock, the longer the shock, the worse it is. And the frequency of the current. It turns out your body runs on certain frequencies. So if we match that, it can mess it up. Turns out the human body is made mostly of water, and it's kind of salty water at that, so it's a decent conductor. So when a shock, electricity goes across the body, it actually kind of likes going through the body. Your muscles are controlled by electrical impulses in the nerves, so a shock can cause the muscles to contract. So let's say you're touching a wire with the palm of your hand. If you get shocked, that'll cause your muscles to contract. And the muscles that close your hand are stronger than the muscles that are used to open your hand. So that causes your fist to clamp around the wire and you can't let go. So if you're testing to see if there's wire is hot by seeing if it shocks you, always use the back of your hand so if it shocks and makes your muscles close, your hands will bend away from the wire. A shock can cause your heart to stop, to kill you. And it turns out your body is most sensitive to 50 to 60 hertz, which just happens to be the frequency of the electricity used in the standard American house or business.